Bismillah ar-Rahman ar-Rahim. This is a question of you can see the top, June 1242 variant, and question number 4. And topic is O-level circles. And if you look at the question, many properties many can implement same time. But the best property which we can start always is this one. So as a teacher, I suggest you, whenever you start any question, try to apply this property first. Can you see, is this meeting? Because this one, look at here, I just explain again to you. This is meeting at A. Okay, this is meeting at A. If this angle is 42 degree, try to find. Can I join another point and meeting at same starting from here? Look at here now. So this arc length is same and meeting here. And this arc length is the same meeting here. So we can say that this angle is also 42. So in this sense, if we look at carefully in this question, so this arc length is CE and they meet at this angle. So it means this angle, whatever, and they meet at this angle, the whatever this angle. So both angles are equal to each other. So I can say easily that's the 42. So this angle is 42, and I can tell you easily this angle is 42. I am writing here 42 degree. And maybe he asking somewhere here. Let me check. CFE. His ask, yeah, CFE is asking here. What is angle? I write here 42. I write here and put a small circle in it. This circle represent a degree. And what's the reason? Angles in a same segment, segment are equal. We have another wording, okay? So angle subtended by same arc or same segment are equal. All right, this is clear. So this part is clear. Now let's discuss one more property. So that property, I think I can concentrate. This is a line is parallel to this line. You can see this arrow, okay? A line cut like this. So this angle and this angle equals to each other. Alternate angle theorem. So look Z format. Z. So Z, whenever Z format, so this angle equals to each other. If you don't understand, I show another example. This line and this line, if they're parallel and a line cut. So this is 42 and this is automatically 42. So this angle I can say without any hesitation 42. And this angle BCA he is asking here. And I can write it here directly 42 degree and alternate angles. Okay, there is one other property, alternate segment theorem. In that property, students, this is the thing is the tangent is important, and this triangle, this angle equal that, and this angle equal that. This is called alternate segment theorem. This is something else and this is something else, so don't mix them. Make sure they are different from each other. So this is done. Now ACE is where? So ACE, he talk about this angle, this triangle. Look, I drew this triangle. He talk about this angle, and I can tell you here he use the word diameter. So this is diameter. And you know a property very important I'm going to show you here. Whenever we have a diameter, this is a O stand for diameter. And whenever any point on the edge of the circle joining to the end of the diameters, so this angle always 90 degree. So this we can say there's the main reason behind it. So ACE, this is a 90 degree. And I'm writing directly here, this is 90 degree. Reason is angle in a semicircle. Angle in a semicircle is right angle word or 90 degree. And let me tell you why semicircle. Whenever we have a diameter, students, so we have one semicircle above and one semicircle below. So that is why this angle make in semicircle. I believe you got my point. And let's talk about the last, CDE. Very interesting, CDE. He tried to confuse you. Many students concentrate only this. What angle, how we can find it. But if you look at carefully, is this cyclic quadrilateral? Exactly correct. Okay, 1 point, second point, third and fourth. All 4 points lie on a circle edge. and this are supplementary angles, and I'm going to show you one more property so you can understand. For example, I make this diagram here. Okay, if I have a 4, 1, 2, third is here, fourth is here. So this angle and this angle, if you add them, supplementary, and this angle, if you add them, supplementary. So I can say directly. So if this is a, how much this angle? So 180 minus 42, 180 minus 42. Out of 10, 2 gone, 8. Out of 7, 4 gone, 3. 138. So we can say this is 138. And what's the reason? We can say that opposite angles in a cyclic. Why is called cyclic, student? Because all 4 points on the circle is called cyclic. Opposite angles in a cyclic quadrilateral are supplementary. Supplementary. I believe you got a point very clear. And the circles over, although this is not discussion point, but anyway, whenever a line touch circle, this is a tangent. So angle between tangent and the radius is 100% 90 degree. And this is called hypotenuse, and this is called adjacent. Or so if I need a PQ, so I'll use Pythagoras theorem. Hypotenuse square equal opposite square plus adjacent square. 12 is a hypotenuse. Okay. And 5 is here coming, 5 square is coming here. And this is a PQ coming here. So PQ to power 2. And 144 is 12 square, 5 will go on other end, 25. And PQ square. And this become 100 and if we subtract them, it becomes 144 minus 25. 144 minus 25, 119 comes. And then you take a root of this, so PQ become root of 119. And we take a root of 119 in 3SF is coming 10.9. And I believe the point is very clear. And main target was a question of circle, and that's over. And question is completely